What if charging your car took less time than brewing a cup of coffee and didn't require lithium at all? You heard it right, Tesla is about to turn this concept into a reality. Let's explore the science behind Tesla's new aluminum-ion super battery. Chapter 1. From Dominance to Disruption: Why Lithium's Reign is Ending. For the last decade, lithium has been the uncontested king of the electric revolution. From smartphones to EVs, it has powered the dream. But kings don't reign forever, and so lithium is also running out of room to grow. The more EVs we build, the more pressure piles onto a fragile, expensive, and geopolitically messy supply chain. Every Tesla, every BYD, and basically everything electric is built on lithium. But here's the catch: lithium isn't easy to find, it isn't easy to process, and it isn't getting any cheaper either. The more the world demands, the more rare and volatile it becomes. Lithium is not just expensive, it's becoming a bottleneck. A high-performance, fire-prone bottleneck that's slowing down the very future it helped build. So, if you're Tesla, and you're not just building cars but trying to electrify homes, power grids, and entire continents, you start looking around for an escape hatch. A material that's cheaper, faster, safer. Something you can build with at scale, without handing your future to a cartel of foreign suppliers. Chapter 2. The Quiet Revolution Inside Tesla. A new battery breaks cover. This development began with a series of silent breakthroughs behind the closed doors of Tesla's battery division. Prototypes behaving in ways no one quite expected. Some of the engineers had been skeptical about using aluminum at first. Aluminum, as in kitchen foil and soda cans. Well, it felt almost too simple, but the early data didn't lie. These batteries were clearly outperforming expectations across the board. Faster charging, lower heat, longer cycle life, and most importantly, safer under stress. The design was honestly a little too smart. Aluminum foil formed the anode, also known as the negative side of the battery. Graphene, that ultra-light and ultra-strong layer of carbon, handled the cathode. In short, there were no exotic metals or any fire risk present. And the real kicker? Charging speeds that didn't feel real. We're talking 60 times faster than lithium-ion. Some test cells were hitting full charge in under 2 minutes. Not 80%, not close enough. Full, no overheating, no waiting. Word started spreading inside the company. Quiet excitement turned into active planning. Chapter 3. How it works. The science behind 5-minute charging. Let's break this down, because now, the hype must be backed by some chemistry. At its core, a battery is a simple machine. 2 electrodes, one positive, one negative, and an electrolyte that lets ions pass between them. In lithium batteries, those ions are, of course, lithium. They move back and forth as the battery charges and discharges. So, why replace lithium with aluminum? Well, the aluminum ions move way faster. And when you pair aluminum with a graphene cathode, think of it as an ultra-efficient, highway-speed material. You unlock a battery that charges with almost no resistance and hardly any heat. On the negative side, it's just pure aluminum foil. On the positive side, a sheet of graphene. That's it. No rare metals, no fragile balancing act, no thermal instability. Chapter 4. Cheaper cars, safer roads. What this means for drivers. Now picture this. You pull into a charging station, step inside for coffee, and by the time they're calling your name at the counter, your Tesla is fully charged. You didn't wait 40 minutes. You didn't tap around an app to find the fast charger. It just happened. That's the kind of future aluminum-ion batteries are unlocking. Charging times that match, or even beat, gas stations. Cars that are lighter, cheaper, and built from materials found just about everywhere on Earth. And yes, that cheaper part is real. Because aluminum is common. It doesn't require geopolitical gymnastics to acquire, and it doesn't cost a fortune to process. Combine that with the simplified manufacturing pipeline and Tesla's obsession with vertical integration, and suddenly, a sub-$10,000 Model 2 starts looking a whole lot less hypothetical. Then there's weight. Aluminum-ion batteries are lighter than lithium, which means less drag, better range, quicker acceleration. They don't overheat, so they don't need bulky cooling systems. That's less complexity, fewer parts, more reliability. And perhaps most importantly, they're safe. No risk of thermal runaway, no battery fires on the highway, no recalls because of faulty cells. Just stable, consistent energy, no matter the temperature outside or the demand under the hood. Chapter 5. A global power shift. How India, Africa, and China are redrawing the battery map. When lithium ruled the battery world, the supply chain map was pretty narrow. If your country wasn't sitting on a lithium reserve, you were left negotiating, importing, or hoping prices didn't spike overnight. But aluminum flips that script. It's everywhere. In India, vast bauxite reserves stretch across Odisha and Chhattisgarh. Africa's Guinea is one of the biggest exporters of raw aluminum, and it's not just shipping anymore. It's building refineries, hosting investments, and demanding a seat at the battery table. Even the US has strong domestic reserves, which completely changes the math on supply and control. And China? They're already a step ahead. After cornering the lithium market for years, they're now quietly locking down aluminum infrastructure too, pouring billions into mines and refining operations across Africa. They know where this is going. But here's what makes it different this time. Aluminum isn't locked to a handful of high-stakes players. It's a shared resource. That creates a much more balanced, open global battery economy, one that doesn't hinge on 5 companies in 3 countries. Chapter 6. The Scramble to Catch Up. How Toyota, BYD, and VW are reacting. The moment the aluminum-ion story leaked, you could feel the shift ripple through the industry. Toyota, which had been cautiously towing the EV line for years with its hybrids and solid-state promises, suddenly had to pivot. Behind the scenes, their R&D labs in Japan began shifting focus, quietly testing aluminum-ion cell designs, retooling equipment, and racing to secure supply deals. The message was clear. If this tech scales, they can't afford to be late again. Then there's BYD. Their Blade battery had positioned them as a serious rival to Tesla, especially in Asia. But aluminum changes the equation. It's lighter, faster, safer. Their engineers are now deep into prototype territory, reportedly even exploring in-house aluminum chemistry. The goal isn't just to catch up, it's to survive the next disruption. Volkswagen, meanwhile, is pouring resources into its Power CO unit. They've already shifted attention from solid-state exclusivity to a broader portfolio, including aluminum-ion. Chapter 7. The second chapter of E5, Tesla's boldest bet yet. Every shift in technology starts with a spark, a change that feels small at first but turns out to rewrite the rules. The aluminum-ion battery might be that moment for EVs. Lithium got us here. It built the momentum, broke through the combustion engine era, and proved electric could scale. But it came with baggage, limited supply, unstable chemistry, and costs that kept EVs just out of reach for millions. Aluminum doesn't just solve those problems, it resets the terms entirely. This isn't just about faster charging or lighter weight. It's about what becomes possible when you take away the bottlenecks. Suddenly, you're not designing around limitations. You're building without them. Imagine EVs that charge in minutes, never catch fire, cost half as much to produce and last twice as long. Not in a decade, not in concept cars, but in actual production lines within the next few years. And it's not just cars, it's home batteries, grid storage, mobile devices, aerospace. Basically anywhere lithium had a grip, aluminum is moving in. Elon Musk didn't just chase this for novelty. He saw the writing on the wall. The growth curve was unsustainable under lithium's constraints. The only way to make electric truly global, truly universal, was to break the dependency before it broke the vision. And now, with working prototypes, a global supply chain forming, and the industry watching nervously, it's clear, this isn't a side project. It's Tesla's next big leap. The lithium era gave us the dream, but the aluminum era? That's where we make it real.